Hey scholars, we are actually studying trig now. We're doing in chapter 9, and we're actually going to combine two lessons to get the overall picture of the chapter and work on that, and then we're going to work with the details on this. And the first thing I need to remind you is how to solve for right sides of right triangles. And the first method we used was the Pythagorean theorem. And you have to know two sides, right? So the thing is, if I know two sides, I can use the Pythagorean theorem. Do your triples include in this? Yes, they really do. Then the next one that we had used, we used our special right triangles. Now the problem with the special right triangles is you have to have a 30, 60, or 45 degree acute angle, and you have to have one side. But the cool thing, it works every single time for a 30, 60, 90, or a 45, 45, 90 triangle, but it's very limited to those two types. So today we're going to learn the next method of solving for missing sides, and we're going to be using trigonometric ratios. Well, trigonometry is the study of triangles and their angles and the side relationships, and in fact you can do a whole course on this. We include that in our pre-calculus course here. But we're going to use ratios. Now what's a trig ratio? It's a ratio of two sides of a right triangle. Why do these work? All because of similar triangles. So everything's based off of the angles, the acute angles of the triangle. So for instance, I'm going to let A always be, I'm going to call it my red angle, and I'm going to let B always be my blue. And I'm going to actually use this stuff to help me figure it out. Now one thing that's always the same is that our hypotenuse is always opposite the right angle. It's always the hypotenuse. We'll never refer to it otherwise. But we're going to use two other terms, adjacent leg and opposite leg. And here's what I mean by this. An adjacent leg is the leg of the two legs that's going to be what? They're going to be next to. And so this would be the one that's next to A. This is your adjacent leg, which means this would be your opposite leg. Now remember, opposite side and angles still hold true for this when I work with these. But if I'm looking at the blue angle, my adjacent leg and opposite leg switch. The adjacent leg helps make it because it's next to it. But then this becomes my opposite leg. So we use that to reference the different parts of the right triangles. And the angle is the key because the angle lets me know what's adjacent or what's opposite. So here's our first definition. The sine, S-I-N-E, we abbreviate it S-I-N, but the sine of an angle is the ratio of the length of the opposite side, oops, excuse me, I should say opposite side, leg, to the length of the hypotenuse. Now here's kind of the cool part here. I can actually write this as a ratio, and it makes an equation of it. The sine of an angle, we're just going to say, is going to be opposite leg, and we're going to have it like this, over hypotenuse. So that way I always know what the ratio is. So now I do it for each one. So we're going to do the sine of angle A. Well, what's the opposite leg's length for angle A? Well, that's A. The hypotenuse is still the hypotenuse, so that's C. So that's going to be A over C. Now looking at B, I want the sine of angle B. I go opposite over hypotenuse, so that's B over C. So notice, remember, adjacent leg and opposite legs change for each angle. Then our next one is the cosine. Okay, the cosine of an angle is the following. It is the ratio of the length of the adjacent leg to the length of the hypotenuse. Alright, so when I do the cosine, we say the cosine, and you put your angle in here, equals adjacent leg over hypotenuse. So let's go back now to what we have. For angle A, your adjacent leg is B because it's the one in red. So we go B over C. Now, I'm going to do for my cosine of B, we're going to use adjacent leg over hypotenuse, so it's the blue, so it's A over C. Alright, not too hard with those. Now I'm actually going to flip back and forth to the next page, and then we'll actually work some problems together of setting these up. So the last ratio that we have, okay, is going to be the tangent of an angle, and its abbreviation is tangent, is tan, and we still say tangent, all right? So the tangent of an angle is the following. The ratio of the length of the opposite leg to the length of the adjacent leg. All right, so what's my abbreviation? Opposite leg over adjacent leg. All right, so those are going to be our values. So now, using the same type of idea that we did from before, we're going to do tangent of angle A. That's opposite leg over adjacent leg. That's going to be A over B. Notice no hypotenuse this time. If I go tangent of angle B, we go over here. Here's angle B. I want opposite leg over adjacent leg. That's going to be B over A. Notice these are the reciprocals. All right, those are the reciprocals. All right, for time-wise, we're not going to worry about the decimal rounded to the nearest hundredth. That's not going to help us right now. We need to be able to set up the ratios. So I'm going to stop here to give us a quick break, and then we're going to go ahead and start the problems.